Baik, Assalamualaikum. Very good morning. Selamat pagi semua. We're gonna continue our session this morning, right? So this morning, we'll do some revisions and we're gonna continue the next topic, which is on the repetitions. Hopefully, we can finish the topics by this week. And as you already learned on the last week, we already talked about several kind of the control flow in the computer program. If you still remember the sequentials, which is a step by step without any kind of conditions. And then last week we talked about the conditions by using the if else, by using a Python language. We have a if conditions, and then we do the implementation, the execution of the if conditions. If true, so we will execute the whatever that inside the true conditions. And then later we learn about the else statement, meaning that we have multiple of conditions in the computer programs, how we handle multiple of the condition in the computer programs by using the elif statement. So before that, we do some revisions. Introduction to computer programming, we already touched on the last week, and also how to read the computer programs starting from the first week, second week, third week. We talk a lot of things regarding this one. And this slide is actually some kind of the repetitions that we do in the last week, right? It's just more on just a little bit details on this slide actually. Okay, so last week you learned about how to able and understand a computer program and how you visualize the computer codes in the form of flowchart. Learn about the flowchart, how you can design the computer program into the flowcharts. What is flowchart actually is a graphical representations of the computer programs. So example that I give you some codes. The first one here, what is the variable in memory input and output of below if data input are 10 and also 90. So this is the example of the questions that you need to trace out the output of the program if the input that user key in are 10 and also 90. So what is happening here is that, okay, so A will be 10 and also 90 will be the input for the variable B. So you need to do some what you call tracing here. So A is A and B is B. So this value comes from the user that can enter is 10 and also 90. So what is happening if we do some kind of the manipulations in the computer program? So you need to know what is happening in each line here. Let's say, for example, this line, okay, C equal to B is one of we want to hold the data temporarily that's held by the variable B. Let's say A is 10, B is 90. So B is right now is 90, will be held by the variable C. Currently, we have two variables that holds the same value of 90, C and also B. So by using the assignment operator, C is equal to B. So the next line here is B equal to A, meaning that, so A have a value of 10, meaning that A will be stored into the variable B. But remember that the previous line, C equal to B, so in this line, B equal to input from the user key in, which is currently the value of B is 90. If we have B equal to A, this is meaning that we replace the current of 90 into the latest value, which means that 10 will replace the value of 90 in the variable B. So currently you will have the value of 10 in variable C, right? In the variable B. So the next line here, A equal to C, means that, so if you look at C equal to B is 90. 90 is equal to, 90 will be assigned into variable A. So line number C equal to B, B equal to A equal to C is one of the way that we can switch the value between two variables. If you still remember that our first exercise that you need to swap the value from the two variables. Okay, some of you just switch the position of A and B. The right way that you do is that you need to have another variables that holds the temporary of the value. Can be come from the either one variable. So the next part here is just print out the output after we do the swapping process. So A will become 90, B equal to 10. All right. So the next part here, B equal to 30, is another assignment. So current value of B before will be replaced by the new value, which is a 30. So A equal to A plus B is another mathematical formula, very simple one. And you need to print out what is the output right here. So this is another example of how you need to trace out. Maybe this question is come through for your maybe test. Okay. You need to do that one. Okay, you need to understand how you need to evaluate the program. So without any running the computer program, without any, you copy the code into the, and you got the output. So you can trace out one by one. Here A 90, then you do some tracing here, replace this number value and so on, and then later we got the output. We have another example too here, that we do the same thing. So meaning said we need to trace out what happenings in this code by using the data input of 10 and also 90. The same things we do the tracing here. In this syllabus, you need to know how to trace the output of the program as well. So, and of course, you need to know how you visualize again the codes that you write down into the flowchart. So what I mean of the graphical representation is that last week I already talked about the diamond shape, parallelogram, the oval shape, the arrow, and so on. That is we call as the graphical representation of the computer program. The same things again. So this example 3, we put the conditions in the code. So you need to trace out what is the output if we put the inputs is 10, 40, 80, and also 90. So what is the output that we got if we put this kind of thing? So the example here, you need to trace out what is the output of 4 user inputs. So the first input is 10. You gain 10 for the variable A, right? So you need to trace out what is happening inside here. Let's say 10. Currently B is equal to 0. We put 10 for the variable A. So 0 plus 10 is 10, and assigned into variable B, which is currently 0, will be replaced to 10. If 10 is greater than 20, so we print out this statement. So we don't have any otherwise here because we don't have any else. So anything inside here will be executed if A is greater than 10 is true. But right now, is it 10 is greater than 20? No, it's false. So it will do the statement outside the conditions, which is this line. So you need to enter A again. For example, let's say A is 10, right? 10 plus A is 10, B equal to 10. So the A is 10 and B is, so you need to know how to trace out this one. Okay. So currently B is 10. This one is 10. So here also will be 10. So your A here also is 10. If you enter here is 10. So 10 plus 10 is equal to 20. So the A is 10 and B is 20. So the output is dependent on what are the inputs that key in by the user. If 40 here, so you need to trace out line by line. Okay, starting from this line, you enter 40 for this line, will be assigned to variable A. So 0 plus 40, B is equal to 40. So is it A, which means that currently is 40 is greater than 20? Yes, it will implement this statement. So print A is 40 and B is, what is it? So 0 plus 40 is 40. So enter this input again and so on. So this is what kind of we call, you need to understand the logical thinking in the computer program. So you need to know what are the executions of the computer program if we input this kind of the value. And this computer program consists of the conditions. It's very careful. You need to do this one because it will give some kind of the different output, right? So similar things on the question number 4 here, the same things, right? Maybe the position is quite different. Okay, so we move on the flowchart here. Last week we already talked about flowchart as well. Okay, what is flowchart? Flowchart is the way that we need to visualize clearly about the execution computer programs. Okay, instruction by the use of arrows, blocks, and also descriptions. Right. So what about arrows here means that the relation between the previous block and also the current blocks. So what is a block here we got here? Okay, refer again our previous line, which is we have a parallelogram, we have a diagram, we have a square diagram, and so on. Oval for the start and also the end of the flow chart. So in this slide as well, there are a few samples of flowchart for each completed codes. Okay, very simple example. Draw flowchart to represent the computer program below. We only have 4 lines of computer codes that represent inputs, process, and also output. So W and also L here represent the inputs. How we can represent 2 lines of inputs from the computer program here into the flowchart, or otherwise from flowchart into the computer program, right? So the best way that we can do before we start for a computer program is that we need to visualize the flow of your program first before you write the code. So you need to know how many inputs that you need to have in the computer program, right? What kind of the calculations involved, right? Is there any conversions from integer to float? Is there any conversion from float to integer? Is there any conversion into centimeter to meter, whatever, and so on? Does the computer program have the conditions you need to design by using the diamond shape, right? And then you need to put the arrow that represent the relationship between blocks, right? Okay. So this is a very simple way, right? So we can represent the flowchart look like this one. Very simple way. So we need to have the starting point of the flowchart by having the oval shape, right? So just imagine this is oval shape, start and also the end. Okay. So if you're writing down start and also the end here, without any process of this in between of it, you still got mark maybe 0.5 mark, right? Because there is a way we marking of your flowchart. So back on the computer program just now, we map again into the flowchart. So how many inputs that we have? We have 2 inputs that represent W and also L. Okay, W represent the width, L represent the length, and then the next step that we need to do is we calculate the area of this rectangle. All right. Okay. So what are the suitable shape for each of the blocks that we need to put here? Okay. To start, we need to use the oval, and we need to use the oval, right? Okay. This one inputs, all right? So inputs here, supposedly we need to use the parallelogram. So it's a little bit, there is slightly what I call here, the angle of the edge of left and right here is supposedly not this way, but we need to use the what do you call input assignment. Okay, it's not this one. Okay, it's not this one. The rectangle shape is only for the process. Okay, like area equal to W multiplied by L, right? Okay, so we know that this is a sequential process, one by one. Input W, input L, and then we do some process, and then we print out the output by using this statement. right? So if we look again from the previous slide, the computer codes, okay, it's represent step by step, but in term of graphical representation, visualization. So this is the purpose of the flow chart. Okay, you represent into the flow chart, right? So we have another example of how we can represent a flow chart. Instead of we are having too lengthy of words in the flow chart, we may reduce the words, right? Starting from this one, it like computer programs, it look like computer program. But this one is not suitable for flowchart because it's too lengthy. So we can represent like this one. If you still remember how you can design the algorithms, right? So what is algorithm is the English words that represent instructions step by step. Okay, get width, get length, okay, do calculate a for calculate area for by using width and also the length, and then display the area and so on. So this is another way to represent for the flowcharts. We compare from the previous slide. It's too lengthy, right? Compared to this one, a very formal way, English words, and it's very easy to understand. You can use instead of get here, you can use enter W or insert W and so on. Okay, that represent the same thing. So for if you pass this flowchart for your friend, for the other friend that you want to share, so your friend will understand it. Okay, so the first flow is present. Okay, I need to key in input. Okay, input of W, and then I need to key in another input of length L. Then later, if I done for two inputs, I need to do some calculations, right? So this is the way that we do. Compared to the computer programs, okay, it may be difficult for your level to understand it because for beginner something like that, how the flow is going on. So if I give you this flow chart, okay, first thing I need to do this one, and so on. So the last thing here, we need to display the output, right? So in terms of the two flowchart that I present just now, we have another way, right? Okay. So since computer program requires to the logical thinking, right? Logical thinking means that you can have different kind of idea how you can represent the computer codes of the computer programs. Okay. So this is another short way, okay, by removing one blocks in the one blocks in the flowchart. Previously, we have four in between start and end, 1, 2, 3, 4 blocks. But this one, we reduce only 3 blocks. Because of what? Since the first and also the second blocks, this one, first and also the second block represent the same instruction, which is input instructions. So we can combine it together into the same blocks and like this way, right? You may look familiar regarding this one because this looks like the algorithm that we do last week, which is we compound together the same instructions, which is input instruction, into the same line of the algorithm. Get W, get L, get W, comma, comma, and so on. But make sure that all the instructions have the same things, right? Input instruction and so on, right? So let's say you have another, what you call, this is only one formula, okay, one formula. Let's say you have another formula. You can combine it together into the same block here, below it, okay, below for it. The same block, you put it, let's say, below here, you want to do something, okay, A equal to A multiplied by A, right? Since these two lines, all right, belong to the same, what we call the process of multiplications or mathematical formula, you can combine it together into the same things, right? To the same block of the flowchart. Okay, right? So this is another example we have here. I don't want to talk too much on this one because the slides already given to you. You can try to look this one, understand it, and this is part of the lesson that I provide to you last week. Actually. So we just go through for this one. If you have anything, any query you want to say, just let me know. Right? So we have two inputs. Identify this one. There are two inputs. Okay, and then we have the process of mathematics, and we have condition here. Okay, how we can represent this condition into the computer programs. If you still remember, condition must use the diamond shape, right? Left and also right that represent false and also true. What are the blocks that represent the true? What are the false blocks that represent the false? And the false statement, the false status, true status. Okay, so we try to learn this one. Get V1, V2 are the inputs. If equal to V1 minus V1, here is the process, simple mathematics, and using the diamond shape that represent the condition. If is less than 0, what should you do? Right? So you want to do this one. If this one is true, I want to do this one. Otherwise, okay, it's false. I want to do this one. Okay, straight away. Okay, if this one is true, I want to do this one. All right, and blah 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 blah, blah calculate and put it what this way to display the difference of the two values. So this is another way that represent the conditions. All right, we can put the condition in the computer programs. Depends what are the case study that you are looking for. Right. So this example, you need to find the difference, okay, difference. Without any flow, okay, without any the conditions that finding the difference, we recap again our last exercise last week. Okay, the difference here, you will get a positive and also negative value, right? If you don't have any the conditions here, right? For example, okay, value one here, V1 here is 10, V2 here is 5. Sorry, V1 here is 10, V2 here is 20, right? So if we use this case study without any flowchart here, right? Straight away to this formula, if 10 minus 20, you will get minus 10. Okay? If assume that you don't have any this one, the conditions here. So the output here difference is negative 10, right? Logically it's true, but in terms of the way that represent for different is negative, no, it's not true. The good way different is must be in the positive, right? Either is a backward and so on, right? It must be a positive value, right? So if you put here 20 and also 10, you got a positive value. Different is 10. But the way that you key in the inputs, all right, is sideways. 10 also 20, 20 and also 10, right? But we can put the condition here to make sure that all the value for different variables will become positive value, right? So there's a lot of example in this slide you can go through, right? So this is additional from the first case study just now by adding another process in the false statement, right? Try to look to this one, V2 minus V1, we have a V1 minus V2, okay? If the condition is true, we want to execute this statement. And if this statement executed, it will go to the next statement below of the conditions. right? Okay. So this is another way, the simplest way. This one is the lengthy word. We just only copy paste the codes from the program and put it in the flowchart. It's not a good way, but the best way is this one. More simpler, okay, more understandable, right? And easy to read the diagram. Get V1, V2, we do some checking here. Either the condition is true or false. If true, go here and it will execute this statement. If the condition is false, it will do the false statement right after below the if statement here. Okay, right? So another example, you can look on this one, right? Okay. So these are the exercise that you need to understand this one, right? So there are several kind of the exercise that you need to trace out the output of the program. If you don't rewrite again the code, right? You can understand it one by one. Okay. So I will share this one. Okay. Later I will put this one into the column. All right. You can do some kind of the tracing out the output for this one. All right. Okay. All right. Or maybe I will transform this one into the Google form. And what you can do is just key in the output for every data that we have here, right? Okay. Okay.
Doctor,
Yes.
for the flowchart, will it come out the question like that for test or quiz?
Maybe. All right.
Okay.
So that's why you need to remember the flowchart. Okay. Very important because it's part of the what you call the cost outcome CO. That you do able to visualize or map the computer program into the proper way. The proper way to visualize it by using the flowcharts, okay, and also the algorithm. You got it, Raj? Are you Raj?
No, Amiral.
Amirul. You got the idea, Amirul?
Yes. Also, doctor,
Yes.
flowchart is like it's just like algorithm, right? But only in shapes and symbols.
Yes, correct. If I repeat again, like I just mentioned just now, it looks like algorithm, but you represent into the flowchart, into the diagram. Is it? Okay. So that's why the best way that you can do before you are writing down the computer program, try to visualize the flow of your program first, right? And then you transform the algorithm, the flow chart into the computer program. So what I mean computer program is the coding, the coding. That's why in your previous quiz one, right? So majority of you does know how to represent into the algorithm and then transform into the flowchart. If you have the algorithm, I need to look again your computer codes, either the sequence of or the step by step in the algorithm is actually mapped in your computer programs. So if you have match of the step in the algorithm and also in the computer program, so meanings that you are able to visualize correctly. Okay. So there is the meaning of that. You should be able to visualize or map the computer program into the proper way. So if you achieve this one, so means that you achieve the course outcome of the syllabus. Right? Any questions? I have another part that I need to cover, just a little bit. Ada lagi soalan? Any questions?
No, okay.
Okay. All right. So you may not have any question right now. So you may have question after you do some exercise. It's okay. So that is part of the learning curve, right? So I want to move for the second part here, right? Okay. And I will continue for tomorrow. Okay, can you see my slide? Repetition instruction.
Yes.
Yes, Doctor.
Okay, have you downloaded the slide?
Yes.
Yes.
Alright, okay. So you may try to look on my slide first. Okay. Later you can print out the slide as a hard copy, or you want to keep as a soft copy, it's up to you, right? Maybe you have a tablet, iPad, Samsung, whatever, and so on. You want to look again in your device, right? Some of students don't want to print out, okay? Some students want to keep in the mobile phone and so on, right? Okay. So we move on the second part of the control flow, which is that we call as the repetitions. Okay, repetitions. Just now, I talk about the if else, if, elif, else, and so on. We call this one as the control statement. Okay, control statement. We are controlling the program by using the if else statement. What if happening if we input this data, right? Does it will go to the true statement or the else statement? Does will go to the false statement and so on? Is how you represent the computer program by using your logical thinking, right? It depends. Some of people have different kind of logical thinking, but at the end of the computer programs, the end of the output of your computer programs will get the same output, but the flow may be look different. Okay, so this is the unique of the computer program actually. Okay, so we move on the second part of the control program, which is we call as a repetitions. Can someone give me the idea what is repetition actually? Apa repetitions? What is repetition? Okay, repetition is some kind of the we are doing the same thing again and again, right? Imagine that you are a staff at the McDonald KFC. Kita pasal makanan pagi-pagi. Saya tak breakfast lagi ni. You are staff in the McDonald, right? You are taking order from the customer, all right? Customer one, okay? Assume that in the drive-through situations, one customer come, okay? You will say, okay, you want to order which one? Okay, menu 1, 2, 3, and so on. Okay, and so on. So settle for the customer number 1, right? So staff number 2 will do the payment, all right? Settle down the payment and so on. So come for the customer 2, we do the same thing. We'll order some menu and so on. Customer will do the payment. So come from the comes again, customer number 3, 4, 5, 6, 7, and so on until at the end of the day, until the McDonald's close the service. So this one of the example that we are doing the same thing again, again, and again, and so on, right? In our daily life, right? Okay. So you can imagine that repetition is one of example that routines repeated. Okay. You are waking up in the morning, you will pray for subuh and so on. Okay. And then you take a breakfast, you go to the class, okay. During the 1 p.m., you go for the lunch with your friend and so on. The same thing you will do for the next day, third day, okay, fifth day, and so on. You will do the same thing again and again, right? So this is what we call the repetitions in our daily life. But how we can represent the repetitions in the computer program? Okay, so that's why we must have repetitions in the computer program in order to control your program actually. All right, okay. So the lesson outcome of this topic is that you learn how to repeat the instructions. Remember that we have multiple instructions. We have input instructions, process instructions, we have output instructions, okay? And then we have another one here that we call as a control instructions using repetition instructions, okay? So the thing is that is become more control in the computer programs. It doesn't have you write down coding 1, 2, 3, 4, 5, and so on straight away without any conditions, without any controlling. Okay. Another example is that okay, you want to control the program. You as a user design okay. You as a programmer design the computer program that the user they can choose the menu. Okay. So let's say example, choose a menu. Okay, you already designed the computer program. Menu A will go to this one, menu B will execute this one, menu C is going to this one, right? So that kind of thing is one of the control statement. And then you want to do repeat again for the next customer. Okay, enter menu, choose menu. So user will choose menu, blah, 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 and so on. Right, that done for the customer number 2. Customer number 3, using the same program, choose menu, it will then and then so on, then all right, and so on. So that is the repetition instructions. You are keep doing the same thing, but maybe the value during the repetitions is different. Customer number 1 choose burger. Customer number 2 choose fried chicken. Customer number 3 maybe just a fries only. So that kind of the attribute is maybe different during the repetition, but it will do the same task. Request user to key in a menu. Customer number 1 choosing burger. Customer number 2, right? Choose menu, choosing the fried chicken. Customer number 3, last one, choosing the fries only. Okay. So example in computer program, how we can represent this one. Okay, assume that you are displaying okay hi there 4 times. How you can represent hi there in the computer program 4 times? Okay, so we can do like this one straight away. This is what you call as sequentials, linearly. We print out this one, 2, 3, 4, 5, and so on. So hi there will be printed out 4 times. Hello, can you see my slide?
Yes, doctor.
Okay, sorry. Okay. Okay. So how we can present hi there here? Okay, you look here, hi there is 4 times, right? Repeated 4 times. In computer program, we can design our codes more simpler by using the for looping. Okay, for repetitions instructions. Okay, for is very powerful technique in the computer programs, not only for the Python, but for the other language as well. Then we can do some repetition again and again, right? Then we can control how many repetition that we can do, right? So example here, for n is variable that we declare in range bracket here. Range is another function that represent how many that you want to do. Okay, range here is, if I want to talk a lot of this one, is a list instruction actually that represent 0, 1, 2, 3. Okay, 0, 1, 2, 3. Supposedly it's only 4 times in this one, right? Okay, it's okay, but this is 4 times, not 3, because it's including 0. So if we repeat again, 1 is 0, is 0, 1, 2, 3. So if we print out 4 times, right? So before I end the class, you said this one, okay? want to open my Tony. I'll give you example by using the same code, this one, how the for loops will execute. Okay, right. So let's say here you want to print display hello 4 times, right? Okay, so you may think about a print hello 4 times. Print hello, right? And then I just copy, paste, 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 and I want to print out here another for complete. Okay, run the program. Okay, so you will have here 4 times hello world. Hello 1, 2, 3, 4. So this is traditional way, sequential technique, one by one, right? But this one is all the thing is the same thing, repeated, right? So we can use for and later I'll talk about what is n actually. In range for double dot, meaning that this become the same block of the for loops, similar things that we do in the if else statement, right? So we print out hello. So what is happening here is we try to run a program. Okay, the same thing. It do the same thing again. It do the same thing again. So what I'm trying to say here is that for is one of the examples that we can do to make sure that we want to repeat the same thing again and again, right? Okay. So and here that represent the variables. You declare variables. Okay. Okay. So what actually range here? Range here is another what you call instructions that represent a list of numbers. If you put here 4, meaning that it represents 0, 1, 2, and also 3. Okay, 4 is not included because 4 is a stopping point. Okay, so 4 here is not included. So that's why it's stop until number 3. Okay? It's include until number 3 because it stopped until number 5. 4. So you can design here to accept, let's say 100 and so on. For example, 10. Okay, so if 10, you need to put here 10. Okay, so it will print out 10 times. 1, okay, 1, 2, 3, 4, 5, 6, 7, 10. Completed. Okay, just put here only 2 or 3, so on. Okay. So you are controlling the program. And you want to display 4 times, 3 times, 2 times, it depends on the input here range. Okay, so the idea here, range is instructions that represent a list of number. Remember that range represent a list of number. If you put it 4, it's starting from value 0, 0, 1, 2, 3. And each of the numbers, okay, that inside this list actually represent the n. Okay, loop number 1 is n here will be 0. 0, it will print out hello, right? And loop again, it will increment by 1. Okay, so is what doing here is n plus 1 that we want to do the next repeated. Okay, so 0 plus 1 is 1, so this one will become 1. Okay, and then here n right now is 0 plus 1. Okay, it's 1, and then it will do 1 plus 1. Okay, it become 2 here until each one will become 3, as each one is 4, right? So is it 4 in the range of this list? No, it's not in the range of this list, but it will break out the for loops. It will execute the complete statement. So this is what is happening in the for loop actually, right? To make you more understand, you can try to use step into features in the Tony. What is it? This one. Click on the debug current script, right? And then you click on the step into, or you can press out the F7 buttons. Click here, right? It will go to the range here. What is range actually? So it will see here, its range actually is starting from 0 and until the last number, 4 minus 1 is 3. Step into again. Okay, so we are starting from 0. Okay, it's print out this one, right? Do again 1, right? This one is 1, 2, 3, and so on. So since 4 is not included in this list, it will not be executed, right? Okay. So this is the idea of the repetitions in the computer programs, right? So I think that that's it for right now.